let me get started. Hello, everyone. Thanks for joining. Hopefully, you got some good sessions today, right? It's Friday. I know some of you might be working, right? I am also kind of working. So let's get started, right? So today's talk is on GraphQL. And if you didn't know, this is the GraphQL logo. And, it's been around for a while. If you don't know the history, Facebook outsourced this about 5 years ago, 6 years ago, something like that. Pretty powerful. So even I was a skeptic, and I work for a financial, and I used it in a project about 2 years ago or so. And I'll tell you, like, it's really good, right? And from my experience, it's worth it, right? So let's see why it's worth it and what it does and so on. So I'm not sure if any of you are familiar, but I'll start from zero and, kind of give you an intro, and then we'll go into the code, right? The code will be primarily in Node.js, JavaScript today, but you can write this in any language, including C#, etc. So we'll go over that too. And again, feel free to stop me. I don't think I can look at the chat while I'm presenting, but again, I'll try to look at it once in a while. Okay, so where do you start, right? So there's a lot of material. Like I said, it's been around a while. You can actually go to graphql.org, which is the website which kind of governs GraphQL, right? And I'm on this page, and it kind of says, okay, why you should use it and so on. We'll go over that. And like I said, it's more of a pattern. You can implement it in any language. Each language has its own framework which supports GraphQL, right? And Python has it, Node.js, JavaScript has it, Java has it, .NET has it, and so on, right? So let's see. So I'm going to start top down. So what I'm going to do is just go to an Explorer, kind of show you a couple of examples of what GraphQL can do, right? So I'm here. So what is GraphQL, right? GraphQL is basically a web service. So what I've launched here on the screen is basically an Explorer where I can explore my web service, right? So let me run the web service. Okay. So like I said, it's a Node.js application. Let me move this a bit. Okay. Okay, my server is running. So I'll just go to the Explorer, which is part of the Apollo stack, which we'll go through in a minute. But if I refresh this Explorer, I kind of get a graphical view of the web server, right? So right there, you have a pretty big advantage. People can go and self-service and so on, right? So these are the different methods supported. And there's a whole schema explorer and so on. You can go and check what queries are supported. For example, there's a books query, books by title query, books by titles query, and so on, right? You can look at objects, what objects are part of the web service, and so on, right? So let me go to the execution part. So let me go to the books, right? So if I click on this plus sign, I get my books query, right? So what's happening here? Okay. So what's happening here? This is the query, right? It looks nothing like a web service query. It's a little bit of a custom query, right? It's not even a JSON. If you see, it can be a bit confusing at the beginning. Again, I don't know the rationale why it's not even a JSON, but it works, right? It's not a drawback or an issue. So let's query this. So let me go play this. So I get a list of books, right? And of course, the output is JSON. Everything looks good. It's normal JSON. Everything is fine, right? Now, let's say that I don't want this title. Actually, that doesn't make any sense. So let me say that I need one more field called genre, right? So, okay. So this other application, which is interested in genre, gets it, right? And you get this additional field now, right? And let's say for some reason you don't care about the author, fine, let's take it out. Okay, so that's cool. So, just imagine you're writing an application which has lots of fields. What happens? One consumer comes to you and says, oh, I need these 3 fields. And then another one comes and says, I need these 5 fields. And the third guy says, you have all these 100 fields. I just need 2 of them, right? Why should I get all your 100 fields and pay for the performance? And just imagine if this list was like, thousands, right? You'd pay a lot of performance penalty. So basically, take what you need, right? You don't have to take stuff that you're not interested in, right? That's pretty powerful concept. Okay, so there are a couple other things which I'm going to go over, but before that, let me go over the code, right? And cover how exactly this is done. It's pretty straightforward code, not a whole lot of moving parts there. So any questions so far? Check the chat if there is any question. Okay, doesn't look like, right? So let me continue. So again, if you need the sample code, again, everything is on Google. There's a Hello World on Free Code Camp. I'll post these slides on the .NET Code Camp, and then you can read that. So what are the key concepts, right? So you need a schema. Basically to tell, what are the objects involved in your web service. You need some methods which describe, books by title, books by titles, and so on and so forth. We'll come to the mutation in a minute. You need something called resolvers, right, which is basically the glue which takes your data and then gives it back to the presentation layer, right? And then we'll go over a couple of slightly more advanced topics, nested resolvers and async resolvers. So first, let's look at the code, right? How complex is it? So here is my code. It's fairly self-explanatory. Okay, first of all, there is a book object, right? So book object has title, author, and genre. And then there is a query. So you can query books, which gives you all the books that are available, right? It's an array, as you see from a square bracket. And then there is the book by title. It gives you one book given as title, right? And then there is the books by titles, right? And we just looked at these books. In fact, we can quickly look at the book by title. So let's say I'm done with this. So let's go back to my book by title. I'll hit the plus sign, and then I'll just ask for whatever I need, right? So let's say, so what is the title? Let me just copy paste one of these guys. All right, let's see. All right, you got one book, right? Same way, the books by titles, as the name indicates, it lets you put in more than one book, right? One title, right? So if I do this plus sign, if you see, okay, what's going on with this? Why is the method signature not coming? That's interesting. Okay, there you go. All right, so I can, now paste an array of titles, right? So, and so on and so forth. Okay. All right, let me run it. Okay, both are back. Yeah, and then again, same thing applies. You can ask for more fields, less fields, doesn't matter. Okay, so let's go look at the code. So we covered the schema, right? And we covered the queries that are supported. Now, obviously, you need something to implement this query. So for this example, I'm using a canned JSON, but we'll see a bit more advanced code in a minute. But okay, so this is the most important part, right? So this is the these are the resolvers. So what is this resolver doing? So it's supporting the books method, which returns the books, which actually has been loaded here, right? So it's a data, where is my data? Here we go. So I have a books JSON with a few books in it, right? And then, so this is simply returning the books. And of course, this is returning the book that matches the title. Again, this is all TypeScript, nothing, this is not specific to GraphQL per se, right? You could write it in C# and then this could be C#. And then books by titles returns it by all the books that match the list of titles that you got, right? So this is an array and then this is single, okay? And this is the code which bootstraps the Apollo server. Like I said, Apollo is a JavaScript implementation of GraphQL. They also support the Python, but then there's a different project which supports the Java version, different project which supports the .NET version, right? That's it. So this is the code, right? As simple as that. And then I'm running the node simple.js, just like any node project. That's it, right? It's up and running. And since I'm running it through Apollo, I'm getting this Explorer view, right? Apollo automatically hosts this Explorer view, but then there is a web server behind this. So how do I know there's a web server behind this? Let's go to the client. Let's see how I would write any client, right? So let's look at this. Okay, so this is my JavaScript client. So what does it do? It's posting a query, right? The query is basically, this is the query. Again, it's not JSON. You got to get used to it. There is no comma around this, right? So I'm posting this query, and then let's see what I get back. So let me run the client. Okay. Okay, my client is running on 3000. Okay, there you go. You got the JSON back, right, in your client. So pretty much, if you're writing a client app, you make this call just like any web service call, and you consume the JSON. Okay, any questions so far? All right, okay. No questions. We'll continue. Let's go to a slightly more, I wouldn't say sophisticated, right? More interesting piece of code. Okay, where did it go? Let's see, simple. Where is my nested? Okay. All right, cool. So I have another piece of code here, right? Which is slightly more interesting. Now, I added a node called author info, right? Author info is an object, okay? I mean, ideally, you want to allow an array of authors, right? A book can have multiple authors. But just to keep it simple, it's a single object for the author info, right? So what does author info contain? Author info contains an author and a period, right? So again, the same thing, queries books by title, books by titles, etc. Right? So let me go ahead and run this. Let me stop the client. There's nothing more interesting in the client. Let's go to our server. So let me stop the server. Let me just run the nested. Okay. Again, it's running on the 4000. So I'm going to go refresh my Explorer, which brings up the new schema, right? So every time if I change my schema, I should refresh this so I get the new schema. So again, everything is fine, but let me just open up a new tab for my query. Let's say books. Okay, hit the plus sign. Now you see books. author, which we had before, genre, title. Then now we have this interesting embedded object. Now, the moment I add that, it asks me, what do you need from this, right? So let's say I need the period. Maybe you don't need the author because you already got it, or you could just say, hey, give me the author here, for example, right? So there you go. And then if I execute it, I got a parent object, which is books. I got an author info, which is a child object. Right? How cool is that? Now, again, this is no different from my other example. I can take this out and I could just get this. So what happened here? So this is a just-in-time evaluation, right? So there was no call for the child object because I never asked for it. But if I paste this in, it goes and asks for the child resolver to give the child object, and then I get the child object, right? And I could have child of the child and so on and so forth, right? So it allows nesting. Obviously, you want to stop at a certain point, and of course, make sure it's not cyclic. But nothing to stop you. So let's look at the code. Okay, so we looked at the schema, right? We looked at the queries, right? And here you go. What is special here is these three are same, right? Nothing changed here. But what is special here is the author in the book. I created a resolver for the book, right? I'm saying within book, I have something called author info, which is actually a child object. So you need to resolve it this way. So I get the parent, right? Parent is nothing but the book. And then I take the author on the book and try to match it with my author. So what is authors? Authors is again a canned JSON, right? Which has the author and the period. So if I go back, so I'm matching the book that's passed in and with any authors from my author list, right? And then if one matches, I return that back. Okay, so every time it hits a book, it calls this guy and then it gets it, right? We'll go a bit more into detail in a minute, in a few minutes. Maybe it's not ideal to call this author info every time this book, every time, if there are 1,000 books, you're going to make 1,000 author info calls, right? But again, that's a different aspect of it. But as simple as that, right? So again, my other code is all canned code, which we have seen before, right? That's it. My code is up and running. So just in time, right? We looked at it. Take what you need, right? You don't need this field, take it out, and you just get what you want back. Completely typed. I can't, for example, make a typo, right? The moment I do that, I get a syntax error. Self-service, right? You can go and explore the schema, right? Like for example, in my company, the implementation we did was for a bunch of people who did not need to come to us, right? It was like ours was a data service. We were giving out like client and account and position, and if think of like a brokerage account, right? So we were giving out that data, and I don't want everybody to come and ask me, hey, do you have this field? And what is this field? Is it a string, a date, or this or that? I didn't want them to come to me, right? So we just gave this explorer. They went there, explored it, they came up with their query, and then boom, they are up and running, right? All they had to do was get the entitlements to make that call, obviously, right? And then that's it. Then they could plug it into their client, and just like any web service, they could query. Okay. Obviously, since it's typed, if you think of it, you cannot delete a field, or I cannot rename a field. Like I cannot make title into something else. So you have to be a bit careful about it. but it's like any other service contract. The moment you publish it, right, you shouldn't be breaking that contract. But I can always introduce another field, right? Like special title or something like that. Right, this is fine, right? And then title will exist and special title will exist. Maybe at some point you tell your consumers that title will go away, start using special title, right? So we covered a bunch of concepts so far. Any questions so far? Let me just check if the chat has any questions. No. Okay, either I'm doing very great or you all want to get off and get into the weekend, right? So cool. So let's go to the presentation now. Let's see what is next. Okay, so we covered schema, we covered the query. We're going to cover mutation in a minute. We covered resolvers. We did cover nested resolvers. You saw that the author info child was resolved by a nested resolver, right? So every time a book call was made, the book made a call to the author info and passed in the book, and then the nested resolver took the book's author and matched it and resolved it. So we'll also cover async resolver in another example, right? So let's go to that example. All right, so I'm going to stop this server. I'm going to go to my other example. So, okay. I'm still in the same example. Let's go to the other one. All right. So this is an example that's on the Apollo website, right? So this basically gets the data from SpaceX, right? So it gets all the rocket launches and so on, right? So we look at it. Maybe that's better than talking about it. All right. So I started up my server. Let's go and look at the Explorer. So like I said, I need to refresh it so that I get the new schema now. Let me kill this. I'm not interested in this. Let me start a new one. Okay, so what do we have? We have a launches and launch. So a launch corresponds to, let me hit the plus sign. A launch corresponds to a rocket launch, right? So let's look at it. Okay. All right. Okay. All right. Okay. The model itself is not that great. That's because the SpaceX team keeps changing their API, and then Apollo depends on SpaceX, right? If you see, it's not like it's the launches and then launches again inside that, etc. Right? So if you look at this, again you can also look at it in a table format. Right, but let me look at it in a JSON format. So basically it's giving you a launch. Let me add a couple more details here, right? Let me add the rock site. Let's see. Okay, what else I have? Okay, not everything is coming back, right? So we have the rocket ID and we have some details coming back, right? So this is great. Now, this is coming from the SpaceX website, right? So my code is making a call to the SpaceX website and getting all these details, right, on demand. So I think it's not a whole lot of data, but a good chunk of data, right? And if you see 24.6 milliseconds, so again, it's not as if GraphQL is slowing down anything, right? As performant as any web service. Now, why would you need a GraphQL if you just needed the SpaceX web service, right? Good point. So why do we need it? So we have a field called isBooked, Okay. So what's happening here is that we have extended this SpaceX website, and we have said that anybody who wants to go on a rocket, please come to us. We can help you book a ticket, right? So basically, we have started a new startup which is selling tickets to all these rockets. So let me book a trip, right? So let me say, let me make sure. So I have a small SQLite database here. Okay. So let's see if I have any users. So I don't have a user. So let me go and let me just go and log in so that it has a context. I hard coded the ID just for this demo. Okay, which is fine. So I created a user, and if you see, I have a user, right? You see what happened, right? Now we have a web service and we have a database. Database is on my machine, whereas the web service is on SpaceX site. And let's make sure the user is there. Okay, the user is there. And I have a trip. Let me make sure I delete this trip. We commit it. Okay. Let me make sure the user is there. Okay. I think it cleaned out the user as well, but let me log in. So what do I have? I 8. Since I hard coded the ID for this demo, I just need to change it. Okay. All right. So we have a user. Now we need to book a trip for this user, right? And then if you notice this is a mutation. We'll cover that in a minute. So basically, I'm going to book a trip on this rocket, right? So I have a launch ID. So I'm going to book a trip. So since it has my ID in the context, so it's going to book a trip. Okay. So before that, let me just make sure that the is booked is false. So if you see is booked is false here, and then I come here, the trip, and it was successful. So I come back here. Is booked is true. So I'm actually flying on this Sarah 1 rocket, whenever that is. Okay, cool. So let's look at the trips. So I should have a trip. And yep, not a whole lot of details, but I'm flying, right? So, so what happened here? So I have a mutation, right? Mutation is basically a put, right? A put or update, etc. That's the GraphQL terminology for a update or insert. So these two are mutations. That means they change the data, right? And this is a query. So let's go look at the code. So couple of things, right? Again, one is the user, which is basically using the SQLite database on my machine, and couple of methods here, but most important one being the book trip, right? So book trip basically uses a API, the entity framework kind of API to insert into the database, right? Not very important, and bunch of other parameters. And then the launch basically goes to the SpaceX website and gets the data. Again, I won't go into too many details here, but basically, if you see, it's going into the SpaceX website and getting the details, right? And then let's look at our resolvers. So the resolver, again, most of the work is being done in these two classes, which are the wrapper over the data source. But the important thing is this one, right? The launch. So the launch, the is booked is coming from our local database, right? So what did we do? We did something really powerful. We took two different data sources and combined the results of that and pushed it as one output. Okay, so if the user had to do it, if the client had to do this, they would have had to go to the SpaceX, then they had to call the database, then stitch the two results, send it back. So I can, in fact, do this one here, I'm getting multiple launches, if you see, which might be getting, let's say, thousands of launches. If you see, just this one has true, right? And rest of them have false, right? Because I only booked a trip on that particular rocket. So for the client, now all the complexity is masked. The client did not have to go to two different sources, did not have to figure out stitching the two. More importantly, all these calls are async. That means I can make my launch, get the launch query and my is booked query async, right? Obviously, this is booked requires the launch, so you can't make it async, but I could have other things going on here. I could make async calls, so they could all go in parallel. Again, another complexity masked for the client. They don't have to figure out the threading and whatnot. All that was done. And if you see, the query itself was 296 milliseconds for both the database call and the SpaceX call and the stitching, right? Fairly performant, right? Okay. Any questions so far? We check the chat. If there's any question? No? Okay. All right, cool. So let's go look at a few more things. Okay. So we looked at async resolvers, right? Obviously that's the best way to go about it. You don't want to make synchronous calls and hold up your client, and you want it to be as performant as possible. And we looked at mutation, right? Mutation basically let you update the data and may or may not return a result. Okay. All right. So far, so good. Now let's go look at the features, right? And to do that, I let the GraphQL website talk more about it. So ask for what you need and get exactly that, right? That's what we did. We asked for a few fields and we got just those fields back. We didn't have any wasted bandwidth, right? And I didn't have to write any additional code to do that, right? As a developer, for me, it's pretty straightforward. Then get many sources in a single request. We got the data from SpaceX. We got the data from my local database, stitched it, sent it back, right? You don't have to worry about, and again, the other important thing is that this resolvers, like, let me go to the books example, right? So if you look at this books example, the book resolver, they're all loosely coupled. I mean, the fact that this parent, this guy knows that the parent is a book is fine. But again, I could have another author info based on some other parent, right? They are all loosely coupled. The author object itself doesn't have to do a whole lot to know what book contains, right? And the parent can be anything, it doesn't matter. And the child object can get embedded anywhere, right? The child object has no knowledge of the parent. So it's very loosely coupled, right? So that's pretty strong. So let's go back. So you get many requests, resources in a single request, very important, right? So describe what's possible with the type system. It's typed, right? So you can't make a mistake since it's all fully typed, right? And as you saw, I could nest another object inside another object. In this case, the friends is an array of characters. So that's nested in there. Okay. Move fast with powerful developer tools, right? We saw that, like, we have this explorer, which basically gives me the self-service capability, right? I can explore the schema. I can explore all the data types, the queries, try it out, right? To do a hello world on it and get comfortable, right? Which I'll tell you, like in an enterprise, it's a huge value add, right? You don't want you don't want people coming to you for trivial questions and waste your time, but more importantly, it's annoying to the user to come to you, right? Because you may be on a meeting and not answer, or you may not be a very nice person and so on, right? So cool. And there is one more thing here. So you can actually do a contract right here and then go and write your code, right? You can actually type the schema here and then go and write the code. So it really enables contract first, right? So cool. What else? Okay, evolve your API without version. So this is another important thing. Whether or not you realized it, but basically, like I said, you can actually keep extending this. You can add an author info. Tomorrow, you could add a publisher info, and so on and so forth, right? So your API, your facade remains same. Your facade doesn't change, but your backend implementation can keep extending it, and so on and so forth. The other important thing is your SpaceX, for example, could be changing a field. You don't care. Your GraphQL endpoint doesn't change, right? That stays constant. And there is another feature which is called aliasing. Let's see if it's there. So you can actually alias. Okay, so I can alias my ID as is booked, for example, right? Let's say your client doesn't like your spelling, right? Maybe you are British and you typed it in a different way. They can use the American English to alias it, right? And that gives you another escape hatch in case somebody renamed something or whatever it is, right? Okay, so that's another important concept. Bring your own data and code. That's probably not that important. Okay, all right. So let's go to what's next. Okay, so far so good. I think we have another 20-ish, 15-ish minute. So we'll cover a few more things. So typed, as you saw, no under or over fetching, right? We just get what you want. Joins, right? Very, very powerful. So in my project, like I was talking, it's like it's think of it like so let's say, so I provide it's a data, think of it like a data lake, right? So so it's a financial thing. So I ask for a client, right? So let's say I want Ravi's details, fine, right? And I could also have a clients here. So I could ask Ravi and Ravi's spouse and so on. Now, next I can ask for accounts on the clients. Okay. So let's say I have an account called A1, and then I have an account called A2. Okay. So I can get all these in a single call. Now I can say that, hey, give me this account one is a brokerage account. Give me all the positions held on that account. Let's say IBM, Apple, and all our favorite companies. So, and then you can ask for IBM's instrument details. Let's say IBM current price, right? Traded volume and so on. So all these are, if you, I'm pretty sure you have similar data sets. And if in an enterprise, every data piece is kept in different places, maybe a mainframe and so on and so forth. So you can really write like these powerful joins, and again, when you wrote these accounts, you never knew that you're going to expose positions and so on and so forth, right? So it's extremely powerful, if I may say so. So contract first, right? You could start writing your schema. As you saw, the GraphQL schema is completely independent of your backend schema. You could write your contract first and then go implement it. it's self-documenting. Okay, this is another important thing. So for example, if I go to my resolver, okay, so what I can do is, let's say in my book, I can actually type a description. Okay, books. Okay, now let's restart our server. First, let me kill the other server. All right. So where did I do that? In the nested? Okay, fine. So if I refresh my resolver, okay. Okay, if I go to my books, sorry, I'm in the query. Let me go to the entity. Okay, there you go. Books give you knowledge, right? So it's kind of self-documenting. As you go along, you can add comments and make sure your self-service users are using that, right? So that's important. And again, all of this is translatable to the language that you work on. Like Apollo gives you Python and JavaScript. Java has its own implementation. .NET has its own implementation. We'll take a quick look in a minute. Like I said, loosely coupled, right? The resolvers don't need to know about each other, so you can write them independent of each other. Just-in-time nested resolution, as we saw, like unless you ask for a child object, it is not the resolver is not called. So you're not paying the price for any data that you never asked for, right? So it's keeping performance in mind. As you saw, it's pretty fast, and I can tell you, like my app gives out like 200 requests per second, right? There is one more reason for that. That's because of horizontally scalable. So if you see, if I just use my database, right, I would have had to keep scaling my database, up, right? Database usually cannot scale horizontally unless it's a not only SQL database. So to me, that's very, very important because I use Oracle and my GraphQL is completely horizontally scalable. So rather than do the join of my clients and accounts and positions in the database, I would rather do it in GraphQL. And GraphQL, my Java can thread it and asynchronous and whatnot. So very, very important, right? So quite a few features. So let's look at the use cases. Okay, where would you use it in your project? So you may need to aggregate data from multiple granular microservices, right? So in this modern world, everybody writes these small microservices because you want to keep it as loosely coupled as possible, right? So, and then what happens? Like if you go to, let's say, some product page on Walmart or somewhere, what happens on this particular page? Let's say I look at this. What happens? You are displaying the product page. You're getting a image. You're also saying, okay, you may also like this. So you are at least accessing around 10 to 15 different disparate data sources, right? Here, reviews and so on. What happens? The guy who wrote this product web service doesn't have to care about your cart or reviews and so on. They can all come from different places. But then the web page itself cares about making 200 calls to the backend, right? It doesn't want to make 200 calls. Maybe it wants to compress those 200 into 10 calls or 5 calls, right? If possible. So GraphQL enables that. Quite powerful. The adapter pattern, right? As you saw, like my SpaceX schema doesn't have to be the same that's being served out to my clients. SpaceX can keep changing their schema. I just need to update my code and then it'll all work, right? Quite important. Replace relational joins in application tier. We talked about it, right? And that makes your application horizontally scalable. Very, very powerful. I'm telling you, like, there must have been at least 2 or 3 presentation on containers today on Philly.net, right? So containers are big. Okay, consume data from disparate data sources. We saw that, right? We reduced the complexity by going to a SpaceX website, web service, and then we went to the database itself. So self-documenting and explorable. Like I said, in my project, I didn't want all my users to spend time to, pinging our team, understanding the whole service with self-service, right? So pretty important concept, right? So with that, I have a couple more slides and hopefully a funny cartoon. But any questions at this point? No? Okay, cool. All right. So I don't know if this made any sense. If you have to explain a joke, then it's not a joke. But if you work with AWS a lot, you probably know what is EC2 and what is S3. And this one, if you work with network, you should know what this is, right? So a small joke on that. All right, cool. Okay, advanced concepts, right? So almost all of these, Apollo and all that, they provide you a caching feature. So let's say your books are not refreshed very frequently, right? So maybe the books are refreshed every hour or something like that. So you can do some micro caching within your application layer so that you don't go to your source very frequently, right? Again, it's up to you. You could always do an external cache instead of doing a application level cache, but it's a simple annotation you put on the attribute you put on your method, and then it'll cache the entities that you ask it to. Batching. So what is batching? So this example we were talking about, right? So what happened? So I asked for clients first, and then I said, give me the accounts for those clients, and then I said, give me all the positions for those accounts, and so on. So what happens? Let's assume that we ended up with total about 100 accounts. Okay, so what do databases love? Databases love one is they allow a primary key index, right? So let's say key equal to, let's say account ID equal to 234. They allow this, right? But then they also allow one more thing. Yeah, as long as you have an index on this, you can say this, right? So databases allow this, and again, other sources allow it too, depending on what your source is. So what does batching do? So batching is a concept in GraphQL where you say that wait until you have collected all the account requests, right? Like let's say the client has, you're returning 5 clients who end up with 100 accounts. So wait until all the client calls are made, and then you take these 100 accounts and again batch them, right? If you want to send 10 accounts at a time in one call, that's fine. So you make this call in a batch. Okay, that increases the performance. I'm telling you, like I use this quite a bit, really improves performance, right? Federation. So what's federation? I think we have 5 more minutes. What's federation? So federation is basically every large company has many departments, and they all provide different services, right? So you have all these web services, and instead of your clients writing this application, which actually calls all these departments, getting the data, and then doing it, you can actually do a GraphQL federation. That's a concept within Apollo framework where you can say that, hey, you federate between these 5 other GraphQLs, right? And then Apollo will federate. Okay, and there is something called AWS AppSync. What is the AWS AppSync? AWS AppSync is basically providing you a GraphQL implementation within AWS. All you have to do is write resolvers, right? So you go here, just write your resolver, and then that can get your data from anywhere. Could get it from an Azure web service somewhere, or you could get it from any of the AWS sources, and so on and so forth, or on-premise data source, and so on. Okay, can be anything. So again, quite powerful. If you think it's useful, just go and explore. There are tutorials which tell you how to write resolvers, combine resolvers, and so on, right? Again, same thing, right? So you see mutation and so on. This, I believe, is a JavaScript. Yeah, it's also a JavaScript. You can also use a Python implementation, whatever you need, right? So it's as simple as going and writing resolvers and setting up a AppSync endpoint. Okay. I think with that, I'm pretty much done. I just have one last slide, which is the references, which I'll post on the Philly.net anyway. And that's about it as far as the presentation goes. Any questions? Okay, I assume that's a no. I don't see any questions on the chat either. So there are no questions. Thank you very much. Have a great weekend.